everybody, to warm up today before our lesson, we're going to solve a few equations here, just a little quick review. If we look at number 1, I see we've got those variables on both sides. I can see we're going to have variable Topia on the left with 8x and Constantinople on the right. So my first move is going to be subtract 6x from both sides, line it up with its like term. So we get 2x minus 12 equals 36. We'll add 12 to both sides. 2x is equal to 48. Divide both sides by 2 and we get x equals 24. Nice stroll down memory lane. As we look at equation number 2, 5x minus 16 plus 7x minus 20 equals 90. We want to combine our like terms. 5x plus 7x is 12x. Negative 16 minus 20 is negative 36, equal to 90. Let's add 36 to both sides to isolate our variable term. 12x is equal to 126. We'll divide both sides by 12 here, and x is equal to, right now we have the fraction 126 over 12. I know that's not going to go in perfectly, so we can just reduce, or we can make it a mixed number. Let's see. So if we reduce, right, figure we take out 2, that's going to be 63 over 6, okay, which are both divisible by 3. So that would be 21 over 2, or 10 and a half, right? So let's say x equals 21 over 2, or 10 and a half, or those of you who prefer your decimals, 10.5. Okay, so now we're going to transition to talking about our main focus for today, which is looking at 3 types of angles: vertical, complementary, and supplementary angles. And let's first start talking about our complementary and our supplementary angles. You might want a random sheet of paper just to jot down a few notes here. The first angle relationship we're going to look at are called complementary angles. And that means any pair of angles that add up to 90 degrees. And we see that here where we have an angle of 35 degrees and an angle of 55 degrees. They add together to make 90 degrees. And these are a special pair because they're also adjacent, meaning they're right next to each other, and we see that because they share this common ray right here. And it's a nice visual because we can see them. They make that perfect 90-degree angle with that box. Angles don't have to be adjacent and sharing a common ray to be complementary. They could also be separate from one another and still just adding up to 90 degrees. That our 40-degree angle plus our 50-degree angle is our 90-degree angle. Okay, and we'll use this algebraically in a moment. Now, a fun little trick to remember that 2 angles are complementary. If we take the word complementary and where you see the C, put a line down, it makes a 90 degrees. Fun little trick there. Then we have our supplementary angle relationships. If you remember, we discussed this in our Do Now yesterday while we were finding the 3 unknowns in the triangle. As we moved to figure out x and then to y, we said they formed a straight angle here, and that straight angles are 180 degrees, so those angles must add up to 180 degrees. And that's our definition of supplementary angles. Angles that add up to 180 degrees. And we see that here with 150 degrees and 30 degrees. And like our first example of the complementary, this angle pair is also adjacent as they share that common ray together, going from 150 and then over to 30, completing that straight line. Like our complementary angles, they don't necessarily have to be adjacent. They could be separate, and we know they're still supplementary because they add up to 180 degrees. Okay? Supplementary also has a cool little word trick. It's a little more complicated though. We're going to take our S, connect the ends, put a loop over our U, and put a 1 there, and it makes a little 180 degrees. So a nice little remember there. Supplementary angles. So our final angle relationships today are vertical angles, and those are formed by two intersecting lines. We've got two intersecting lines here. They intersect at this point here, which we call the vertex, making four angles. We've got a top-bottom angle pair, and we've got a left-right angle pair. And we're going to do a little geometry proof just to identify the relationship between vertical angles. I'm telling you that this angle up here is 60 degrees, and we're going to use our knowledge of supplementary angles to find the other. I'm going to be rotating the board a little bit, so hopefully this shifting doesn't bother you. So as we know, this top angle up here is 60 degrees. Let's take a look at how that lays on this red line. Okay, so if we look here, this red line, okay, we've got this 60-degree angle, and then we add in this angle here, and they make that straight line, okay, meaning they're supplementary, they must add to 180. So if this angle is 60, this angle must be its supplement, adding to 180, new vocabulary word there, which means it must be 120 degrees, because 60 plus 120 is 180. Okay. Now we're going to rotate again, this time focusing on the blue line. I've got to lift up a little bit here, okay? So we've got this 120 degree angle here from blue line here. To complete to the blue line, we need to make this angle here, which will make it straight, 180. So the supplement there, 120 plus what equals 180, must also be 60 degrees. Okay? And again, if we rotate, and we look at it in terms of this red line, and maybe I'll rewrite so it's not upside down. Right, so we've got this angle here that's 60 degrees. To create that straight red line here, we need another 120 degrees. Okay? So if we just take a look back at our vertical angles, what we should notice is we've made two pairs of congruent or equal angles. That our top-bottom pair are both 60 degrees and equal, and then our left-right pair are both 120 degrees and equal or congruent. So our definition of vertical angles is that opposite angles are congruent, right? Or equal, or we could use our little congruent symbol, okay? Now finally, into our booklet at page 13, we're going to put our angle relationships into practice forming algebraic equations. Okay. First relationship we have here, we've got 3x plus 15 equals 39. What I really want to focus on are these two intersecting lines. I'm going to ignore these pieces up here that kind of make it look like a triangle. That's not what I'm focusing on. So we notice, oh, I've got two intersecting lines, opposite pairs of angles. They must be vertical angles, which tells me they are congruent or they are equal. So we're going to use that to set up our equation. 3x plus 15 equals 39. And then we're just going to solve. So subtract 15 from both sides. We should get 3x equals 24. Divide both sides by 3. And we get x is equal to 8. Now in the directions, we were only asked to solve for x. Sometimes we might be asked to go back and find these angle measures themselves. Okay, so moving on to number 2. Okay, as we can see here, I clearly have complementary angles. They're adding up to 90. So I want to show that our angles add up to 90. 11x plus 35 equals 90 degrees. So we go ahead and we solve. Okay, so we should get 11x is equal to 55. So x is equal to 5. Okay. Final relationship is our supplementary angles. This is the image that students have most difficulty with because they're like, why is there a triangle and a line sticking off it? Don't focus on that. We really want to look at these two angles here that are forming this straight line. So x minus 15 is this angle here, 2x is here. They're forming that straight line. They're supplementary, adding to 180. Let's use that to build our equation. 2x plus x minus 15 equals 180. Combine our like terms. 3x minus 15 equals 180. Add 15 to both sides. 3x equals 195. Divide both sides by 3, and x is going to be equal to 65. Okay? So just to review, we're using our relationships to build our algebraic equations. When we see a straight line supplementary, we're saying our angles add to 180. See that complementary relationship, setting up our equation angles equal to 90. And when we see those vertical angles, setting them equal to each other. That's the only time we're setting our angle measures equal to each other. So now we should be working on pages 14, 15, and 16 in our booklet. And we just want to be careful that we're going through and we're reading our diagrams correctly. If your copy of an image in your booklet you can't really read, feel free to click on the geometry booklet in our weekly outline so you can see the PDF version. Okay? Just know that on page 16, we do sort of go back to using our supplementary angles as well as using our facts about triangles. Okay? And just a reminder, we're going to post all our classwork in our Padlet. Have a great day.